Hello all, hi, welcome to today's session. And today we will be learning about something different, something interesting, and something that we haven't talked about yet. Okay, and that is rays and raycasting. These two are really important concepts in Unity, and they're very useful for doing multiple things in Unity, right? While we are making a game. Okay, but moreover, these are really useful in the world of XR, where we are developing AR, VR, or MR experiences, right? Then most of the time we will be using rays and raycasting. Okay, so let's get started. Let me share my screen. And just before getting started, as always, let's do a quick recap about what we learned about yesterday. Okay, so yesterday we talked about the rigid body, right? We took a deep dive into the rigid body component and had a look at few of the most important properties of rigid body. Okay, like mass, drag, angular drag, and constraints. We also talked about constraints, which is freeze rotation and freeze position. Other than that, we also talked about use gravity. We talked about collisions. Okay, and the most important things, we talked about the three methods that are called automatically whenever a collision happens. One is on collision enter, second on collision stay, third on collision exit. Okay, and we created a simple demo as well to use these properties and use these functions. And we created a simple experience in which whenever a cube falls, first of all, we can detect whatever it is touching, right? If it is touching a plane, we specifically did one exercise in which we said, okay, if it is touching a plane, then only change its color, otherwise don't. Okay, and there we used the the concept of tags, right? Tags, and how can we differentiate or identify stuff on the basis of tag, no matter if the name of the ground, name of the game object changes. Okay, then we said we also did some scripting to change the color of the cube whenever it hits anything. So we said whatever it hits, the cube will take the color of that object. Okay, so these are the few things that we did tomorrow. And today, as I already told you, we'll be learning about rays and raycasting. Okay, so okay, today also we'll be doing something different. Okay, I'll not be exactly teaching you. I'll be trying to learn about raycast in front of you. Okay, as if I was a beginner, right? And I would tell you what is a way for you to learn things on your own. For example, if you've heard something about, okay, there are something known as ray and raycasting, so what should be your process of learning it on your own? Okay, this skill is really important, learning on your own, because no course, no book or nothing will give you information about everything. Why? Because Unity or anything is an ever-changing platform, and new updates are added on. Okay, new properties are coming, new functionality is coming. So to learn by yourself is a pretty important skill. As whenever there is a new update or whenever there is something that you don't know, if you know how to learn, you can learn anything, right? So let's take that path today. Okay, and for that I'll be creating a new scene. Let's create a new scene by going to our project window, right clicking, going to create, and then simply clicking on scene. And let's say, let's name it Ray Basics. Okay. Let's open the scene. Again, this is a pretty empty scene. We do not have anything here. We just have a camera and a direction light. Okay. So what shall we do now? We just know something is called ray, okay, and something is ray casting. So what shall we do? First and the foremost thing that we should do is simply Google it out to the documentation. So this says ray scripting API, and this also says physics.raycast. Okay, let's first go to ray. Let's understand rays. Okay, so it says ray, a description is given here, and it says representation of rays. A ray is an infinite line starting at origin and going in some direction. Okay, so it says a ray is an infinite line starting from origin, that is maybe from one point, and it will go infinite in some direction. It will keep going. Okay, so it says it has a constructor, and these are the methods, these are the properties. So get point returns a point at a distance units along the ray, to string, formatted string, and this. Okay, so let's leave this first. Let's see how to create a ray. Okay, so let's click here, constructors, and here we have an example. Okay, so we can create a ray by something like this. So this is an example here. Let's try to understand it and let's try to copy it as well. Okay, let's try to see how it works. Okay, so it says creates a ray starting at the origin along the direction. Okay, so it's saying create a ray from the transform position. Transform means the transform component transform. So it's saying create a ray from the position of the transform. So on whatever game object the script will be there, it will be creating a ray from the very position of the transform along its z axis. Okay, so basically it's saying that if the script is on this game object, right, what it will do is it will create a ray which will whose origin point will be its position and its direction would be the z axis. Okay, if z axis is pointing this way, so a ray will be going this way. Okay, so okay, let's copy this, and we don't know like how things work, right? So let's copy this and let's just see what happens. Okay, let's create a new script. Simply we can create ray basics. Okay, let's create some game object. Okay, let's say we have created a cube. Let's reset its position, so it's 0 0 0. Let's add, no, not the user input, ray basic script. Let's add the script here, and as of now this script is empty, so it shouldn't do anything, but we have copied the example code. Okay, as of now, for example, you didn't understand the example code, just copy it and just try to run it and see what happens. Okay, because if you see it you will understand it. Okay, so I'll just, okay, I won't change the name. So here it says, so what are the things that we understand as of now? So this is a component, script component. Start will be executed as soon as this, the scene starts and uh, this component is, initialized. Okay, as soon as this is initialized, then this start function will work. So when it will start, it will say it will create a ray. So it's created a ray variable, okay, whose type is ray. So this is a ray type of variable in which we're creating a new ray whose origin is the transform position and its direction is forward, that is in z direction. Okay, let's save this, right? Let's go to Unity and let's hit play. So this is in play mode, and what should happen is this should be creating a ray from this very point, that is a position, in the forward direction, that is a z direction. There should be a ray going here. Okay, but the thing is we are not seeing anything. And that, why is that so? Because rays are invisible, right? We do not see any ray. Okay, so how would we see a ray? Okay, we can see a ray. There is a function known as debug dot draw ray, and here we can pass the ray. Okay, so this variable is just local to the start. Let's not do that. Okay. Okay, so it says draw ray should get vector start, direction, color, duration. Okay, so it is saying that give me a direction. It's not taking the ray as it is. So let's give it the direction, the starting point, the direction, and the color. So let's color dot red, and this should be visible easily. Okay, let's save this and let's see. Basically, what we are doing is we are debugging. In debug, basically, there's a function which will help us see a ray. Okay, because otherwise rays are invisible in Unity. Let's click play again and let's see what happens. So are we able to see anything as of now? Yes, it is pretty thin, and that is why in the first look it doesn't, it seems that we are not able to see, but we can see here that there is a red line going here. Okay, let's do one thing. Okay, what we can do is this is forward, so this is 0 0 1. Let's multiply this by 10, so it will be, the direction would be 10 units. Okay, now we should have a bigger ray. Okay, because we've just multiplied the direction by 10, and it should be the same direction, but the ray should be bigger, right? Yes, the ray is bigger, right? So this is a ray. Okay, we have started it from a point which is transformed dot position. We have said in the z direction, and we can change the direction as well. Let's see what happens if we say up. So up means this will be in the y-axis. Okay, and let's change the color to blue. Right? Let's see what happens. You can play again. So as we can see, we are able to see a deeper gray. A ray is drawn here. Okay. So this is a ray. So it's starting from point and then going in a direction that we have specified. So ray is done. So now we know what is a ray, how it works. Okay. So this is simply a ray. Now, what can we actually do with a ray? Okay. What we can do is we can actually point this ray and we can actually get information about wherever this ray is hitting, and then we can do, whatever we want to. Okay. So let me show you a diagram which will help you understand it better. Okay. So this is a diagram, right? Here basically what we can see is this is known as raycasting. Okay, so we are pointing a ray from this very point and we are saying to point it and throw the ray in this direction, and whatever this ray hits we can actually get information about that ray. Okay, and then we can do whatever we want to. For example, a simple example could be if you have played some role playing game which is a fighting game, maybe Call of Duty or maybe Counter Strike games, right, where you have a gun, right? So in that, basically what you're doing is you're shooting a raycast, okay, and you're sending a bullet, okay. Bullet maybe the transform, you can say game object. You're throwing it in that direction, and wherever it hits, right. For example, it hits on a cube, you destroy that cube. Basically, you remove that cube, right? That's how bullets or these guns work in a game. Okay, so if we can simply write a code which says, okay, throw a ray from this very point, okay, and in this direction, and whatever it hits, destroy that. Okay, we'll be creating this very example today itself. Okay, so we'll be learning about now ray casting. Ray is doing nothing, right? But ray casting will be doing something. So in ray casting, let's see what we can do. So now we've understood about rays, right? Again, let's go to ray casting unit. Here we have physics.raycast. And let's see what do we have here. It says this raycast takes so many variables. What exactly are these variables? We will be looking into these. This is origin, we know that. Direction, we know that. So this is basically ray. So ray casting is casting or throwing a ray. So which ray? This will be the ray. A distance. It's saying what should the distance that this ray should go. Okay. Then this says layer mask. We will get into it, and query trigger action. Okay. So layer mask, what it says is a layer mask that is used to selectively ignore colliders when raycasting, and query trigger action is specifies whether this query should hit triggers. Okay. So origin we know, starting point of the ray. Direction we know, direction of the ray. Max distance is the max distance the ray should check for collision. Okay. So if you're throwing a ray from this point, okay, a ray would go here and it will actually collide with things, and we can get the information about this collision. We can get whatever it is hitting. Okay, so max distance says that this ray should, at which distance should it go. Maybe it's 5, so it will just hit objects here. If the max distance is 5 and something is at position, distance 10, it won't be hitting that. Okay, layer mask is if we have a layer, as we had in our last tutorial, where we had a layer on my ground, right? So if we want some objects on a layer to not to be collided by a ray, for example, we have a wall here and we have a cube here, and we don't want this wall to be hit by the ray. So what we can say is we can put this wall on a new layer known as, maybe you can name the layer anything, invisible. Okay, then then provide that layer name here, while passing your arguments. And then this ray won't hit this wall, it will directly pass through the wall and hit the cube. Okay, so yeah, that is about ray casting. And let's see it in action. Okay, so the example here looks pretty big, right? Let's see. So it says example class, the order of execution for information on fixed update and update related to physics queries. Okay. So here it's a new function known as fixed update. Okay. We can have a look at it because till now we were most of the times using update, right? So let's first of all see what update is, which we already have an idea about. Native player can also render a phrase. Fixed update is a C# representation of update phase in a native loop. There it can only be used to identify update phase in native. No, this doesn't give us a pretty good understanding. Okay, let me give you an understanding. So update is known to be called in every frame. Fixed update is known to be called in a specific time. Okay, fixed update will be called after every 1 second, no matter the frame is, whatever the frame is. Okay, this will be called in every specific time. Okay, and this is more or less used for physics calculations, right? So whatever we are concerned about here is from this thing. So we say physics.recast transform dot position, transform dot direction it is saying, and then it's saying out hit. So this out hit is basically a recast hit. So this is a type of a variable which registers all the information about the hit. Whenever the recast hits anything. So we get an information of type recast hit. So we're saying output all the information in this hit variable. Okay. This is the distance. This is math.infinity, and this is the layer mask. If you want to have, they are drawing a debug ray as well, so as to see the ray wherever it is going, right? And yeah, so let's create our own example, and let's do it here itself. So, for first of all, what are the things that we need? Okay, so we can do physics physics dot raycast. Okay, now what are the things that we need? First of all, we need an origin. We can say transform dot position. Then we need the direction. We can say transform dot forward. That is the z direction. Then what else do we need? We need the max distance. Okay. So max distance, let us give it n. Then what we need? These are optional things. Okay. These are default. They are already given. So let's not. We do not want this array to skip any hit. Okay. So here we have transform dot position, the distance, and then we can add a hit stuff as well. Okay, out hit. So what we can do is we can create a raycast hit. Raycast hit type variable hit. Okay, so this is a type of variable. Like this raycast hit is a class which can store all the information whenever a ray hits anything. Okay, and let's say here out hit, and this is the maximum distance. Right, let's debug this way as well. Debug draw, right? And if we want to see if this has hit anything, and then we want to execute a code, then we can simply let us debug the name of whatever it hits. Okay, hit the ray, hit the so all the information that we have is hit in the hit variables, and let's get the hit object. Hit dot name. So what all information can we get from the hit raycast? So it will give us the point, the normal, the distance, the collider. Okay. These are all the things that the raycast kit would give us. So let's see what do we get here. Okay, so let's go and some cube. We have this. Let's simply okay. So it's showing the raycast up because the debug draw that we are doing is in the up direction. We don't want to do that. We want to do it in the forward direction because that is where we are, throwing our ray. Okay. Let's set this to 3 for now. Distance as well 3. Right. Let's create another cube with a sphere. Set its position, like transform component, and position it at maybe 2. Okay. And now let's hit play. So what we'll be doing is we'll be casting a ray. This is hitting the sphere, and this is saying the ray hit unity hit recast. Okay. So this is giving us the name. Like this is saying that we hit it. Okay. What if we increase the value? Now we do not have anything being printed here because this is out of the range of this array, and this is not hitting anything, right? Let's create a variable max distance so that we can actually change it from the editor itself and provide it here, right? Say is hit dot provide the dot name. So now we'll be getting the name of whatever we are hitting, right? So let's go back. Let's create a capsule. Let's create another cylinder. And right. And now let's hit play. So as of now, this is hitting the sphere. So this says the ray hit the sphere. Okay. As we can see here, the ray is beautifully hitting the sphere. Okay. Now let's see if we change the position of the cube here. Now the ray maximum distance is 3, and it is the cylinder is beyond its max distance. So it is not hitting anything. As you can see, nothing is being printed on the console. But okay, we can make it public, I guess. Okay. Just a second. Let's make this float public as well, so we can change the maximum distance on the go. Okay. So as we see, it is hitting the sphere. It is not hitting the cylinder because that is out of range. But let's change the max distance to 5. Now it is hitting the cylinder, but the ray event C is still here itself. Why? Because in the debug.draw ray, we have said that this would be only 3. Let's change this as well to max distance. Okay. So transform that forward into max distance. That should be the the direction of the ray and of the debug ray, right? So now Come to cylinder, it's not hitting it. We change it to 5. The ray is increased and now it is hitting the cylinder. But again, if we move a bit more, again the capsule is out of the range. Let's increase the range. And now we're hitting the capsule as well, right? So this is a great thing that which we can do, and which this is known as raycasting. Let's simply add a simple thing so as to give you a representation of how we can destroy game objects as well. So first of all, let's call this this raycasting and draw thing on whenever we click something. So input dot get key down keyboard dot maybe H, right? So whenever we press H, then this code shall be executed. Okay. So whenever we will press H, this will be executed, and we want to say the ray hit the object, and we want to destroy that object. Destroy function actually deletes or destroys that game object. We want to destroy whatever object this ray is hitting. So now let's see. Let's clear the console. Let's hit on play. As of now, there will be no ray casted. Okay. Let's go close so that we can see. And now as soon as we click, then only the ray will be casted, and it will be only casted once, right? So we will just see a blink there and the sphere will be gone, right? Let's press H now. The sphere is gone. We have a debug here. The ray hit the sphere. So now we simply we have like hit a ray cast and we have performed an action. Okay, let's do the same here. Okay, so I guess we are not in front of the cylinder. We are in front of the cylinder, but the ray distance is less. Let's increase the ray distance and now hit H. Bam. We are done. We are gone. Right? Again, we are away. So as you can see, a blink. Right? Here you can see a blink. A blue ray is casted. So this is out of the reach of the capsule is out of the reach of this ray. Let's say 10. And it's gone as well. So we just destroyed the sphere, cylinder, and capsule, and as you can see, they're not in the scene, they're not present in the hierarchy as well, right? So that was all from my side today, and we learned today about rays and ray casting, and also we learned how can we learn about things. If we have some idea about things, how can we actually go to the Unity documentation, get to learn, see the example, try to put it on your plate, on your code, and see if that runs, right? How can we actually try things out, right? So this is how you learn, and this is a really important skill that you need to learn. That is how to learn. Because if you know how to learn, you can learn anything. Okay. So that's all from my side. See you guys soon. And a homework for today would be again to create a capsule and make it cast some rays, and whatever it hits, and it should hit a ray whenever you press space, and whatever it hits, it should change its color, right? So that's the homework for you today. See you guys. Enjoy.